Kia ora koutou katoa, it's Mrs. Goodson here, and this is the second video in Chemistry 2.4 Bonding and Structure. So this video follows on from the first video, which was about subatomic particles, protons, electrons, and neutrons. And so you need to watch that one first, and then this one is going to show you how those subatomic particles are linked to the periodic table. So this video is determining how you find the atomic number, the mass number, and therefore the electron configuration for elements 1 to 20 and linking it to the positions on the periodic table. It's also going to talk about isotopes and linking the position. So that's the row and the column of the elements on the periodic table and where we can find them on the periodic table, becoming familiar with the first 20 elements and linking that to the number of protons, neutrons, and electrons, and also the electron configuration. So the periodic table is about 150 years old, and the columns, that's the columns, up and down columns on the periodic table are called groups. Okay, and the rows, you can just call them rows and columns, but the rows are known as periods, all right? So elements in the same group all have the same number of electrons in their valence shells, okay? So they have the same number. If they're in the same column, they have the same number of electrons on the outside. Elements in the same period or the same row have the same number of shells of electrons in their atoms. So we're going to look at that a bit further. So first of all, just to recap on how to determine the number of protons, electrons. Electrons got a negative charge, protons have a positive charge, and neutrons have no charge, remember. So the order of the elements in the periodic table gives the atomic number. So hydrogen is 1, calcium is 20. So those are the ones we need to know for level 2 chemistry. 1 to 20. The atomic number equals the number of protons in an atom. The mass number gives the number of protons plus the number of neutrons. If a substance is an element, it's going to have no charge. It's going to be neither overall positive or overall negative. So that means it's got the same number of electrons. Now, electrons have a charge of -1 and protons have a charge of +1. So that if the number of electrons is the same as the number of protons, then the charge is going to cancel out. And overall atoms of elements have no charge overall. If it is an ion, then it's going to either have a positive charge or a negative charge. And so the number of electrons and the number of protons plus or minus the charge on the ion. So the number of electrons is going to equal the number of protons plus or minus the charge on the ion. So the row or the period that the element is in gives the number of energy levels. So let's look at magnesium. It has an atomic number of 12. That means it's number 12 in the periodic table. It has a symbol. Remember, the symbol is always a capital letter and a lowercase letter or just a capital letter. Its name is magnesium in this case, and it has atomic mass or a mass number of 24. If we round that, it's 24. That means it's got 12 protons, 12 neutrons and 12 electrons. And so that's electron configuration. It fills the shells from the middle. Start with 2, then it's full, then 8, then it's full. Then to get to 12, because we want to get to 12 electrons, we want to add another 2. So 2 plus 8 plus 2 is going to give us 12. And the number 2 on the outside here is the valence electrons. So magnesium has 2 valence electrons. Okay, so in the periodic table, elements have something in common if they are in the same row. All the elements in a period or a row have the same number of energy levels. Okay, so every element in the top row, like hydrogen and helium, has 1 energy level, and then all the elements in the second row, like this row here, has 2 energy levels because the first row got filled up the first energy level, so we need to add another until we get to neon. Then the second energy level is full, so then we go back to the third shell. The third shell has 3 energy levels, and so on. Okay, so the electron configuration or the electron arrangement is a shorthand way of describing the way electrons, so this is all about the negative electrons, are arranged in an atom. Okay, so each energy level is filled to its maximum capacity, starting with the lowest energy level first, and then so we just separate it by a common. So, for example, magnesium has an atomic number of 12, so it's going to have 12 protons and 12 electrons in the element. So the first energy level is 2 and then 8, and then to make it up to 12, remember we've got to get to 12, we're going to add 2 on the end, and that one there is the valence electrons on the outside. So we can use the periodic table to write electron configurations. Can we just see which group it's in? So this example, calcium. So this is number 20, and it's in group 2 or column 2 and row or period 4. Okay. So the last number of the group, so it's in group 2, so it's going to have 2 valence electrons. It's in row 4, so it's going to have 4 shells. 2, 8, 8, 2, 4 shells. 1, 2, 3, 4. 4 shells altogether. The last shell is the group 2, and so that's how we write the electron configuration. So in the periodic table, the elements in the same group or the same column have things in common. So we say that they are in families. So group 1 is known as alkaline metals, group 2 alkaline earth metals. The ones in the middle here, these green ones, are called transition metals. Group 17 over here are halogens or halides also, and then group 18 are noble gases. Okay, so some of their groups have names. And that is the end of our video on the periodic table.